All right, everyone, welcome back. In this unit, we're going to be talking about strings. But before we do that, we need to get introduced to methods. The reason being is that we're going to end up using coding bat in order to kind of practice strings. And coding bat relies a little bit on knowledge about methods in order to do that. We're going to also see some string methods, some pre-existing code basically that already exists that we'll need to use. And so today, even though this whole unit is about strings, we're going to talk about methods. We're going to get introduced to methods. We're going to kind of just briskly glance at methods. In computer science, a procedure or function is a section of code that performs a particular routine. So the idea is we're going to have a section of code. We're effectively going to name it. And instead of just normally executing our code from top to bottom, we'll have bits of code that we can kind of jump to, execute, and then come back based on that. Executing a procedure will alter the normal flow of the program by causing it to jump to the procedure and execute all of the statements within a procedure before returning back to the point at which it was executed. Again, we're going to have a block of code somewhere else, right? Somewhere else within our file. We're going to give that block of code a name. And so as we're executing instructions, we get to basically the name of the procedure. It tells us to jump to a section of code that's maybe somewhere else. We execute that code, and then we come back. Procedures provide a way to express abstraction in computer languages. Now, I kind of hate this word abstraction because it confuses students. This is literally an abstract concept, but let me show you what I mean. For example, the process of brushing your teeth could consist of several steps, right? Maybe you wet your bristles, then you spread your toothpaste over the bristles. Maybe you invert these things. Maybe you spread toothpaste on and then you kind of wet the toothpaste after the fact. Maybe you're a bit of a serial killer and you don't wet the toothpaste or bristles at all. That's not really important. What's important is that we have these steps. Now, these steps kind of make up what we would call an algorithm, right? The literal steps are an algorithm. But if I take all of these steps and wrap them up, I bundle them up, I give them a name, such as brush teeth, that's an abstraction. Okay, so I want you to think of the literal step-by-step as an algorithm. Bundled up together, it's an abstraction, right? So I tell you to brush your teeth, you're going to go brush your teeth how you brush your teeth in the order that you like to brush your teeth. Okay, that may be different from other people. The literal step-by-step is not what's important. The actual abstraction is just brush teeth. In Java, procedures are referred to as methods. So this word procedure, function, method, those are essentially all interchangeable. Java tends to be a little bit of the hipster here, and they use the word method kind of for everything. There are two sides to the method that we will talk about. There's the method call, and there's the method definition. We've actually already encountered some method calls. Here, input.nextInt, system.out.println, hello world, math.square root of 9. Think for a moment, what do all these things have in common? We see the parentheses. That's going to be super important, pretty integral to a method call. Also take a look at this little period. Okay. The parentheses will 100%, you will see those. When we're talking about calling a method, a function, a procedure, parentheses are involved. The period, which we call the method selector in this context, is there most of the time, or a lot of the time. A method call is essentially a command that tells the program to execute a particular method, right? We've seen these. Whenever we tell the program to do system.out.println, it is effectively jumping to a section of code that handles the printing, that puts this into our console. Whenever we call math.square root, we're jumping to a section of code that is somewhere else, it is executing, and then we're coming back. So this is the method call. This is telling the section of code that is defined somewhere else to execute. That is the method call. Sometimes additional information, that is input, will be passed to the method call through the parentheses, right? With our print line, we're passing in information. This is input effectively. When we do PAL, or as we saw with square root, there's additional information. I'd like you to notice that with our print line, there's actually just one piece of information, a string literal. With PAL, there's actually two pieces of information, right? We have our base and our exponent. The data passed to a method, a function, a procedure, through the parentheses is known as arguments. You could also call them parameters. Those words are interchangeable. I tend to call them arguments in the method call, and then call them parameters whenever we look at the method definition, which we'll talk about in just a moment. So the arguments or parameters provided in the method call will be processed by the method and affect the value the method returns, that is output. Think of arguments, think of parameters as input. However, as we see here, a method can return a value, that is, produce an output. Sometimes a method is able to perform an action without any additional information, that is, no arguments are required. Right, with our input.nextInt, this is a scanner method that we have seen, and we're telling our scanner to get the next integer from the console. In theory, nextInt, this could be at random, but I wouldn't name my random variable input. System.print line, nothing here. This is a possibility. This is one way to kind of cause a new line, like a blank line, to be created in your output. The other side of the method that we will talk about is the method definition. The section of code that is actually executed, right? So we're going to take a block of code, we're going to wrap it up, we'll give it a name. That's the method definition. The method call is what tells that block of code to execute. So looking at our syntax for a method definition, we're going to have what we'll call an access modifier, a return type, the name of the method, and then you see some parentheses here. That's where the parameters go. We then see some braces that indicate the body, and we're going to see any number of statements. Could be one, could be more. Probably not one. Usually not one. All right, some quick examples, and then we'll break this apart. We'll talk about each of these parts. We have public, int, max, int x, int y. Right, this is expressed on one line. You would typically spread this out over multiple lines. As we're going to see, we see public, boolean, is prime. A method definition consists of a head or header and a body. You've actually defined a method before. Think for a moment. Look at some of these words, right? Public, parentheses here. Our main method is technically a method. We've used that word, right? Main method. We see public, static, we're just going to gloss over. It's not important to us right now. Void, we'll learn about in just a moment what that actually means. The name of the method is main, and this actually takes in a string array. There's a lot going on here that is beyond what we're talking about right now, but this is technically a method. While there are several access modifiers to choose from, most of the methods we'll be writing will simply use the public access modifier. In fact, all the methods that we will write in this class will be public. There's others available, private for instance, but for what we're doing, public is perfectly fine. So even though the only access modifier we'll be using is public, what this is called is access modifiers, right? So when I ask you, what goes here, I don't want you to say public. I want you to say access modifier. Our return type is whenever a method is called, the body of the method will be executed and a value is returned. A value will be output by the method. The type of data that a method will return is dictated by the method's return type. So we're going to have an output. What goes here is the data type. So we are preemptively saying that this method is going to return some type of data. That could be one of the 8 primitive data types that we've learned, such as int, double, boolean. Right? So we're saying that this method, which is yet to be named, is going to output a boolean value. It could also be an object, and we don't know a lot of objects, but string is one that we're definitely about to dive into. So a method could return an object, such as a string. Other objects we might know are like random. It'd be weird to return that. It'd be random. Scanner, also kind of weird, but those are all data types. And so they all are possibilities of something that the method could return. Whether a primitive data type or an object, a method can only return one value, right? So we can't specify multiple return types. It is possible for a method to perform an action without returning anything at all. A method will simply return, will have a return type of void if it does not return a value, right? We just saw with our main method, we have a void return type. All right, ignore static. We have a void return type. Our main method never actually outputs anything. Like, it never returns a value. Yeah, a lot of times we print some stuff to console, but that is technically different. Okay, we'll see more with void in just a moment. If a method does specify a return type, right? If you put something other than void here, the method's body must contain a reachable return statement. Okay, we'll talk about what reachable means a little bit later. So we're going to have, if we have something other than void here, we're talking things like int, double, boolean, string. Those are all data types. If we specify a data type here, we're going to have a return statement. And simply put, a return statement is return the thing that you're actually returning, semicolon, right? So if I say something like, public int, I could say return 7. In theory, you're doing some calculations. You're actually, you have an algorithm going on that's doing more than just returning 7, but that's the idea. The next piece is the method name. It's going to be any valid user-defined symbol and consist of only the symbols that make up a user-defined symbol. We're talking our capital A through Z, lowercase a through Z, our digits 0 through 9, underscore, $sign. The same stuff that we use to make up variable names are user-defined symbols, and that is what a method can be used to compose a method name. All right, a note here, a reminder, basically, that we cannot begin with a digit, and we can't use reserved words, things like public, void. Note that method names should follow the same conventions as variable names. We should start with a lowercase letter, and we should use camel casing. Here's an example, sleep in, which is effectively 2 words, squished together, so we're using camel casing. The last part that we're going to talk about here are parameters. The variables declared within the parentheses of a method header, known as parameters. Again, when we're looking at the method definition, I tend to use the word parameters, and I use the word arguments whenever we're talking about the method call. But the parameters here dictates the type of data that a method will accept as input. And how do you refer to those things in the method? Let me show you what I'm talking about. A method can define, in theory, 0 to infinite number of parameters. The number is technically the max value of an integer, which is like 2.1 billion. I highly doubt that you will have that many parameters ever. That takes a lot of work to get to that. But 0, when you get to like 3 and 4 parameters, that's actually like a lot, right? You need that much input. But 0, 1, 2 parameters, very common. Each parameter must have a data type and a variable name. A method can specify primitive data types as parameters, such as int. Notice that we have a data type and a variable name. This method, sleep in, has 1 parameter, an integer, x. Here, I'm showing that we can change up the data type and you can change up the variable name. Keep in mind, this is a variable. It's a user-defined symbol. So this one's called double num. Data type, variable name. Here we have a boolean, just kind of demonstrating the concept that any primitive data type works. You can also use objects, right? Objects are data types. Here we're declaring a string, which we're calling str. Again, data type, variable name. If a method specifies multiple parameters, each parameter must be separated by a comma. Here I have integer x, data type, variable name, comma, another data type, variable name. Sleep in, this method accepts 2 inputs, 2 arguments, 2 parameters. Note that parameter names must be unique as they are written within the same scope, right? So I have integer x, double y. I couldn't have integer x, double x. That wouldn't work. Because one of the things that's going to happen is in the body of the method, I need to refer to this data. And the way that I'm going to be able to refer to it is by the variable name. So if both of these things were called x, my method wouldn't know what x you're referring to. You're talking about the integer, you're talking about the double. So they have to have unique names in order to differentiate between them. So here I have 3 parameters, and we're not limited to primitive data types or anything crazy. If it's a data type, it can be used. Here I have string str, integer x, double y. Here I have 2 booleans, kind of indicating that we can use the same data type. That's perfectly fine. In fact, we're going to see a practice problem just like this. The parameter names dictate how we would generically refer to the data passed to the method via the method call. Keep in mind, there's two parts to this method. Somewhere else, we're going to call the method. There's data coming in. The way that I refer to that data is by these variable names here. Some methods are able to perform an action without needing any additional input, thus no parameters. Note that even though we have no parameters here, you still need the parentheses. That's not something that you can omit. The braces that indicate the body of a method are not optional. So methods are not control statements. They're kind of similar, right? They have heads, they got bodies, but these are different. You cannot omit the braces, period. We will rarely have a method with only one. I say that knowing that like one of the very first coding bats can be done with only one line. We will rarely have a method with only one line. But it doesn't matter. The braces aren't optional. You always got to keep them. All right, let's practice this idea. Let's write some methods. So we're going to write a method that returns a maximum of 2 integers. This up here is a method signature. We've actually seen this a couple of times, but I've yet to really talk about what's going on here. What this is saying is that we will have a method called max. Max is going to be defined in the class methods, right? So in IntelliJ, I'm about to make a new project with a new class, and I'm going to call that class methods. And in that class, I'm going to write the actual method called max. Max is going to take in 2 integers. Notice that I have the data types, but not the variable names, because the variable names are up to you. It's not important what the integers are called. What's most important is knowing that max takes 2 integers in order to use, right? The syntax here indicates that this method, max, will return an integer. So max is going to take in 2 integers. It'll return a single integer. And the last thing that this method signature is indicating, this underline indicates that it's static. Don't worry about that. Just know that the line indicates that it's static. You don't need to know what static means yet. Okay? Oh, there's technically our solution. So let's write that. Here I am in IntelliJ. I want to make a new project by going to File, New Project. And we'll go next. We'll go next. I need to jump to my CSP folder, so I will do that. You are likely already in the right spot, so you can just make your methods project name. And I'm going to make sure that I get a subfolder created. I'm going to right click on the SRC, make a new Java class called methods. Okay, I'm going to plug in a main method with PSVM, but we're going to come back to it, right? I'm not actually going to write anything in that. It's important to note that our methods are defined in the body of the class, right? We see that with our main method. So the method that I'm about to define, this max method, needs to be in the body of the class. So I'm going to take this signature and I'm going to translate it into a header. That's what this is. That's what a signature is meant for, right? We're in the class methods. The name of the method is max. Starting out, we'll say public. This underline indicates that it is static. Up next is our return type. Looking at the signature, our return type is int. The name of the method is max, and it's going to take in 2 integers. It's up to us to name them, right? X and Y is perfectly fine here. So this is the method header. I have a body indicated by braces, and these braces are not optional. Okay, here's the idea. Max is going to take in X and Y, and we need to basically output, return, whatever the largest value is. Lots of ways to do this. There's already a max method that exists in the math class. But that being said, somebody had to write that method So here we're just going through the logic. What would a max method look like? Well, a couple of ways to do this, right? Let's take a look at a couple of approaches. I'm going to create an integer. I'm going to call it maximum. It could just be called max. I'm trying to avoid confusing people. And let's start off by saying that maybe x is the maximum. I'm then, however, going to do a check and say if y is actually larger than x, then I'm going to make the maximum be equal to y. So when I get to this point, either x is stored in maximum, or we decided that y is actually larger, and now y is stored in maximum. Regardless, it doesn't matter. Whatever is currently stored in maximum, that variable, we're going to return it. Okay, a couple of things to note. Our method says it will return an integer, and we do. We create this integer here, and ultimately that is what we return. Another thing to note is, what if x and y are like tied? Right? If they're equal, then it doesn't matter. Just return one of them. That is, in fact, what the math.max method does, the max method that's coming out of the math class. Right? In the event that they're equal, just return one of them. It doesn't matter which one. Our particular algorithm, our particular method, is going to return x, right? Because we put x inside of maximum. We ask, is y larger than x? If they're equal, then this is false, and so we don't do this. So technically, x is still stored in maximum. It doesn't matter, as long as you return one of the values in the event that they're equal. So let's test this out. What I have is a method definition. Notice this is grayed out. IntelliJ is saying that, hey, this thing exists, but you never actually called it. Right? Max is gray because I never actually used it. So this definition exists, just waiting to be called. We're going to actually do that up here. I'm going to say max of two numbers, right? I need to pass in two integers. Let's do 2 and 7. Quick note, this syntax you see here, this x colon, this y colon, that's IntelliJ trying to do you a favor, right? Notice that when I first typed this out, we said max 2, 7. I did not say x colon. I did not say y colon. This is gray here. This is IntelliJ trying to tell you, hey, this is what you called this thing. This is what you called this thing. So the actual syntax, right, to call the method, I'll leave it as a comment to keep IntelliJ from doing the auto stuff. It looks like this. We're calling the max method, providing two inputs, a 2 and a 7. 2 is an integer, which is what I need. 7 is an integer, which is what I need. So those are the two inputs coming in. And if I run this, we'll see that our program doesn't break, but it doesn't actually show anything in the console, right? Keep in mind that in order for us to actually see anything in the console, we have to tell our program to print. There is a value being returned right here. What I have highlighted is an integer. Max takes in two values. It should return an integer. It is. There's an integer sitting right here. I've got some options. I could do some math with it. I could save it into a variable. Print me. Right? Notice there are no syntax errors here. That is, IntelliJ is happy. This is returning an integer, and I'm taking that integer, saving into a variable. If I actually want to see it, we can do an S out. Spit, that's pretty close. Do an S out on print me. Okay, 7 is the maximum. Let's take a look here. Let's look at the flow, and then I'll make another change. Our program starts with our main method. First thing that happens is we encounter this line. This side will be executed first. It's going to call max. We jump to this section of code, passing in a 2 and a 7. For the rest of the method, x is 2, y is 7. We're going to save a 2 into our maximum. We're going to ask, is y greater than x? That is 7 greater than 2? It is. So we're going to update our maximum. Our maximum is now a 7. When I get down to this point, we're returning a 7. So it's 7 is being output here. We're saving it into this integer print me, where it is then printed off. Okay. One thing I want to show you is we can actually just do this directly. So, and a value is being output. I don't technically have to save it into a variable, but I did clearly show you that an integer is being returned because I was able to save it into an integer. Here I've executed the program again. We're going to start with our main method. We encounter this print statement. We're going to go inside the parentheses. We're going to execute this, which causes us to jump to the code, executing the exact same thing. A number gets returned. And so here, what I have highlighted is a 7. It's the 7 that's returned by the max method. Quick testing, right? You would want to maybe flip these values to make sure that, the order doesn't matter, right? Our method should determine what the largest value is no matter what the order. What happens if the values are equal? We should just get a 2. And then lastly, let's just try different numbers. I don't know, an 8 and a 4. I still get 8 as the maximum value. And I flip the values again, I still get an 8. So all that looks pretty good. Okay. Of note, in order to do a minimum method, all you got to do is flip this sign. But I'm going to show you a slightly different approach. Right? Keep in mind we need to return an integer. We made a variable to store the value, and we did that. It's pretty intuitive to basically just do an if statement check. Say if x is greater than y, we're going to return x. Okay. First thing I would note here is that we are saying we're going to return an integer, and we are. We're returning x. X is an integer. Otherwise, return y. Okay. Why this is crazy and different is I technically have 2 return statements, right? So isn't this going to return 2 values even though I'm only returning one thing? Well, for one thing, because we are inside of an if statement, right, I'm only going to return one thing or the other. Right? It's not like we're going to do both parts of the if statement. But check this out. I'm going to get rid of the else. Effectively the same code. I'm saying if x is greater than y, we're going to spit back out x. Otherwise, return y, the other value. I have 2 return statements. And I'm going to flip these values to kind of show you that it's still working. And we're going to talk about why this works when kind of in theory it shouldn't. Why am I saying in theory it shouldn't? Well, we can only return one value. I've got 2 return statements. That's kind of weird to begin with. We're going to execute this, return x, and if I were to continue, I would return something else. And in this particular example, right, I would be spitting out 8 and then a 4. All I see is an 8. Okay, that's because of the way a return statement works. The moment that you return, you exit the method, right? So looking at the current execution, we're calling max. We're passing in an 8 and a 4. We're going to ask, is 8 greater than 4? Yes. I'm going to return 8 and exit the method. Done, right? So that technically means you don't need the else. If the values were flipped, I'm passing in a 4 and an 8 in that order. The order matters here, right? Right. This is x, this is y. We're going to ask, is 4 greater than 8? That is false. So we skip this and instead return y, whatever it is. In this case, an 8. Okay. That is our max method. And we're going to actually pause on that note. We'll pick up with methods a little bit later in a different video. See you in the next one.